What makes certain geometry problems impossible to solve classically? Imagine trying to build a perfect square with the same area as a circle using only a straightedge and compass. Or think about dividing an angle into 3 equal parts with just those simple tools. Some puzzles like these have stumped mathematicians for centuries. They seem straightforward but turn out to be impossible with just a straightedge and compass. That's because these problems involve numbers or lengths that can't be created with the basic operations allowed in classical geometry. In classical Euclidean geometry, you can only draw straight lines and circles, then find where they cross. When you do this, the new points you find can only be described by solving linear or quadratic equations. This means the lengths you can construct are limited to numbers you get by adding, subtracting, multiplying, dividing, or taking square roots of known lengths. But some problems need solutions to more complicated equations. For example, squaring the circle requires constructing a length that equals the square root of pi. Pi is a special number called a transcendental number, which means it cannot be expressed as a root of any polynomial with rational coefficients. Because of this, it's impossible to construct that length with just a straightedge and compass. Doubling the cube asks for constructing the cube root of 2. This is a length that solves a cubic equation, which goes beyond the quadratic equations that classical tools can handle. Since the straightedge and compass can only solve quadratic equations, they cannot produce the cube root of 2. Trisecting an arbitrary angle is another tricky problem. While some angles can be divided into 3 equal parts with a straightedge and compass, in general, doing this involves solving cubic equations. Again, these are outside the scope of what classical constructions can achieve. Mathematicians proved these limitations in the 19th century using algebra and number theory. They showed that only certain numbers called constructible numbers can be created with a straightedge and compass. These are numbers you can get by starting with given points and repeatedly performing addition, subtraction, multiplication, division, and square roots. But cube roots and transcendental numbers are not part of this set. So, the reason some geometry problems are impossible to solve classically is because they requiring constructing lengths related to solutions of equations that go beyond quadratic ones. The tools of Euclidean geometry are limited to solving linear and quadratic equations, so they cannot handle the more complex numbers involved in these famous problems. This reveals the fundamental boundaries of classical construction methods and explains why some puzzles remain unsolvable with just a straightedge and compass.